Please welcome Rick Echevarria, VP and General Manager of Intel Platform Security Division.
I'm trying to figure out what was the mystery behind standing there, but it was nothing purposeful. Just anxiously waiting for this moment. Good afternoon, everybody. Really excited to be here to talk about a little bit of hardware-based security. It was about 4 months ago that Team8, who I thank for the opportunity here, gave us that opportunity at Cyber Week. And at that time, I established, or asserted, that the current and the future threat landscape required a new trust calculus. Anybody remember that? Who was there? Yeah, pretty clear, right? And I said that in order to solve for that trust calculus, we needed to deal with 3 variables. The first of those is to really start applying Moore's Law to cybersecurity. The second is that we increase our focus on those workloads that are built with cybersecurity as a matter of course, and workloads that we could use to address the cybersecurity issues of today. Think blockchain, think artificial intelligence for security. And the third one is increasing our cyber-focused collaboration with industry and academia, okay? So basically what I'm going to do this afternoon is I'm going to do a little bit of a report out on those 3 areas, okay? So let me start with the hardware piece and how we're applying Moore's Law to security. And there are 2 technologies that I'm going to focus on. This is going to be a little techy, but I promise you that later on I'm going to bring this up to what we're doing with this technology. But this is very important because understanding how we're able to apply Moore's Law to cybersecurity should open your minds to the art of the possible. We're here to collaborate and to learn what can we build to solve current and future cybersecurity issues. So this first technology is called Software Guard Extensions, SGX. And here's the way to think about SGX. SGX allows any application to open up and own the smallest trusted compute boundary that any application could build for itself, regardless of the state of the device, so they can protect their data, the keys, the memory. And what's really interesting about this technology is that we also built into these secure enclaves the ability for you to cryptographically certify that the computations inside of the enclave are what you're expecting them to deliver to you without revealing the contents inside the enclave. I'm going to talk about 2 specific workloads for which this technology seems to be really gathering momentum. The second hardware-based technology that I want to introduce you to is Enhanced Privacy ID, something we call EPID. And think of the ability to have a hardware-based identity that you can integrate into the silicon, but you can preserve the privacy of the device itself. You can provision and you can support those devices, but you don't have necessarily the ability to identify the device itself. Lots of applications for this technology in the Internet of Things space. So let me talk to you about what we're doing with these technologies. And I'm going to start with SGX, and I mentioned that there were 2 workloads that we're building a lot of momentum with the use of this technology: confidential computing in the cloud, and the second one is blockchain, which I'm sure many of you have heard about, right? Little hyped up. So there are some fundamental security barriers on top of everyone's mind, and most of them have to do with the migration of data and applications to the cloud. And most of these concerns are based on the concept of trust. Who has visibility into my data? Who has access to my applications? And it's an interesting relationship between the people like you and your cloud service providers. And so we're using hardware-based technologies to mitigate a number of these concerns. The picture that you have here, you could probably recognize the colors a little bit. They are based on an announcement, what I would consider a breakthrough announcement in cloud-based security with Azure. And at the time, we announced the fact that we were going to enable a number of different usages that are going to be hardened and protected by hardware around databases, around multi-party machine learning collaborations, data analytics, and key protections. And you're going to see in a few slides that after we make this announcement, a lot of the industry has followed along. The second use of SGX is blockchain. And actually, I spent time last week in the Bay Area talking about how real blockchain is becoming, very fast moving through the curve. And we decided that there were 3 technology problems that our silicon could help address for blockchains: scalability, privacy, and security. And so everywhere you see Intel land work in blockchain, those are the 3 technical problems that we're trying to solve. We want to make sure that there's scalability so that blockchain operates at the speed of your business. We want to make sure that we deliver the privacy that enables you to trust it and really collaborate. And of course, we want to ensure that as you're building smart contracts and other types of applications that are running on top of the blockchain, we do it and deliver it to you in the most secure fashion possible. Okay? Now, in addition to the work that we're doing in silicon, we actually are participating with the Linux Foundation to build our own distributed ledger technology. The reason we're doing that is because we want to make sure that we understand the workload so it can help us build the right roadmap for that opportunity in blockchain. Okay? Lots of work to do here. We're very excited about our industry work here. Lastly, let me talk about the enhanced privacy ID and the work that we're doing in the IoT space. And you understand the issues here. Nadav did a great job of laying out the fact that IoT is creating a massive surface of attack. It's a big challenge for us. And so what we're doing with this enhanced privacy ID is actually using it to build in a service that we call secure device onboarding, so that we can take devices and we can integrate it from their inception into a secure development lifecycle. We announced this about a month ago at the IoT Solutions World with a number of partners. So let me talk about the industry collaborations. That's why we're here. That's the reason why we built this work. We want to help you, help us, help the industry address these cybersecurity challenges. So, SGX, we have over 70 partners in the ecosystem that are delivering solutions for SGX across a number of different usages and segments for which cybersecurity is fundamental. Then there's blockchain, where we have recently made a number of announcements. You can see the list here. There's about 7 more that we've announced during the weeks, and then a lot of them at Money 2020 last week. With our secure device onboarding technology, again, we have a number of partners, cloud service providers, people on the channel, and also microcontroller unit vendors, because we've realized the importance of standards in this space, and we're integrating our identity technology into ARM-based devices. So this is not Intel only. Standards are very important. So finally, our collaborations with academia, and these are very important because they keep us on the leading edge of security technologies. I think we have somebody here from Georgia Tech, one of our collaborators. So the next time we meet, I'm going to focus on 2 areas that are of interest, but I'm almost going to run over. So I won't be able to talk about AI for security or security for autonomous driving, but we'll do that next time. So let me wrap it up, reinforcing 2 commitments. First is our commitment to work tirelessly on these 3 variables of the trust calculus. Moore's law applied to cybersecurity, these emerging workloads for cybersecurity, and then, of course, the collaborations with industry and academia. And last but not least, our commitment to our Team8 collaboration, a collaboration that's going to become a lot more visible in the coming months. Thank you.